Hello Math 20-2 and welcome to your final lesson on quadratic equations. In this lesson we're going to take everything we learned about quadratic equations and apply them to real life situations, real world problems. So here in our first problem we're dealing with a projectile. Projectile shot in the air and the equation for the projectile is this equation here. Now, write a quadratic equation which could be used to determine what time has elapsed when the projectile hit the ground. Okay, so when it hits the ground, our height, because h of t, h obviously stands for height, t stands for time, our height is going to be 0 is equal to negative 4.9, and we have t squared plus 16t plus 2. Okay, now let's continue this up. It says, determine algebraically the height, or how much time it took the projectile to hit the ground. Now looking at this, I look at this negative 4.9. It's not a very nice number. It's not even, it's not anything. If I was to factor this, that'd be a lot of guessing, checking, a lot of calculating. So I'm going to automatically, for this one, because of that number, use the quadratic formula. So if we remember, quadratic formula is, it's also in your formula sheet, negative b squared plus or minus, or negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So let's put this all in. So I have negative 16 plus or minus, so I'm going to say t is equal to plus or minus square root of 16 squared minus 4 multiplied by negative 4.9 multiplied by 2. Okay? Just going to zoom in so you can see that a little bit. Now, we're going to start calculating this out. Okay, so I'm going to get negative 16 plus or minus, oh, this is all over 2a. Plus or minus the square root of, this is going to be 256, negative plus times 2, and that's going to give me 295.2, I believe. All over 2a. Okay? So now I have to go this plus that, and then this minus that, and both of them divided by 2a, which is 2 times 4. 2 times 2, which is 4. That should be 2. Sorry. So then, if we calculate that out, I'm going to get 0.1 for one of them, and the other one I'm going to get 3.4. Now looking at that, I can't have a negative time, can I? So this is wrong, and my only answer is 3.4 seconds. That's it. Let's take a look at the second one here. This one, they also give us our formula. So this one is dealing with a special enlarger, okay? And this enlarger is enlarging photos of this size, and here's the bulb. This is the equation of the parabola of the bulb, and that's the diameter of the bulb. Okay? Now, it says write the equation which could be used to solve the diameter of the reflector bulb. Well, my diameter are my x-intercepts if we look at that. So that is when my height is 0. Again, height is 0. That's the diameter because it's my x-intercepts. So I'm going to put it at 0 is equal to, okay, we have negative 2 over 9 x squared plus 4 over 3 x. Okay? Now, write an equivalent quadratic using only integer values. So these aren't very nice, are they? These fractions. It can be very complicated. But I can multiply everything here, including this, by 9, and I can get rid of all my fractions. Remember, I have to multiply everything by the same thing. So what am I going to be left with? 0 is equal to negative 2 x squared plus 9 times 4 is 36 divided by 3, 12x. That's it. Now, determine the diameter of the bulb for this equation. Now, I could use the quadratic formula, but using the quadratic formula, I'd say would slow me down here, because this is a very fast and easy calculation or factor. So I'm going to have 0. First factor out the 2, because everything here can be divided by 2. And I'm going to be left with negative 2, so this is positive, we always want our x positive, x squared minus 6x. Okay? Now, I'm going to factor out an x. So I have negative 2, and then an x. I'm going to have x subtract 6. Okay? Now this is easy. I have x can equal to 0, or x is equal to 6, because this is equal to 0, or that is equal to 0, right? To make it equal to 0. Now, my radius, or my diameter, isn't going to be 0. That's this x-intercept. That's the start. The end is there. So from here to here is 6 centimeters, because it says my question's in centimeters. So 6 centimeters is the diameter. Okay? Let's take a look at our next one. Our next one here, we're going to have something, a question where we're not given the equation. We have to learn how to make it. So the first thing we must do is introduce a variable. We're going to introduce a variable. Normally we're going to say x for the variable, okay? Second thing we do, I would strongly suggest highlighting this, is form a quadratic equation from the given information. Third thing we're going to do is solve the quadratic equation, then state the solution to the problem, okay? So here we go. First, we have this here. There's a school from the main building to the gym. It's an L shape. And there's a walkway that looks like this, L shape, to school. Now that is 230 meters. Let's sketch the diagram. 230. So from here to here, that's 230. Okay? Now, if you walk across the diagonal, that's only 170 meters. Okay? So it says, if I say one length is x, so let's say this is x, what's the other length going to be? Well, if this plus this length is equal to 230, this length here is going to be 230 subtract x is going to be that length. So 230 subtract x. Okay? Now it says use the Pythagorean theorem to write an equation for x. So the Pythagorean theorem, that's brilliant. That's, well, because this is equal to this squared plus that squared. And now we know we have a representation for that squared and that squared. One variable, that's it. So let's take a look at that. C squared is equal to a squared plus b squared. So 170 squared is equal to x squared plus 230 subtract x squared. Okay, I'm going to start expanding this. It's equal to x squared plus, and we have 230 minus x multiplied by 230 subtract x. Alright, so this here is going to be 2890. Okay, I believe, yep. And we have x squared plus, and I'm going to start solving this. This times that is 52900. And then we're going to have to subtract 460x. So I did this multiplied by that, or sorry, this multiplied by that, and this multiplied by that, and this multiplied by that. So I have two of these, so that's 460x. And then I'm going to have to go plus x squared. Okay, I just kind of simplified it there because this is a long lesson. Now, what do I have to do now is make this equal to 0. Make that equal 0. So we're going to subtract 28900 from both sides. Combine everything on this side. These combine. I'm left with 2x. And I have mine squared. Those are my x squareds. Minus 460x. And we have that's 52900, and we subtract 28900, it's going to give me 2400. That's it. Now, look at this. We have a quadratic equation that's equal to 0. Easier to solve now. So let's factor it out. First thing I'm going to factor out is this 2. So I have a 2. I'm going to left with x squared minus 230x minus 200. Okay? Okay, let's take a look at this. Oh, there should be another 0 there, shouldn't there? Yeah, there should have been another 0. I was 1 0 shy there. When I did the subtraction, there was one more 0. Whoopsie. Okay, so that's good. Now, let's do my box method to factor this out. You could also graph in your calculator. But if you graph in your calculator, you have to think. I would put my x min at 0 and my x max at 250 so we can see every possible dimension. Because my things here is 230 and, well, 230. So we're going to have to be less, it has to be greater than 0 one dimension. The other one has to be less than 230. So you can even say 230 x max, x min 0. Okay? Just to make sure you can see your x-intercepts and then find that way and use that to graph. I'm going to do it the box method because it's faster for me. So I use my box method here, and I have 230, and here I have Okay, now, the way I'm going to think about this, I'm going to cancel this off temporarily. So I have 23, and this is negative, right? So two numbers added together, 23. That makes 120. I'm going to say 15 and 8. 15, 8. Both of those have to be negative. And because we put back in the zeros, this is going to be 0, 0. Okay? So, we factor this out. I'm going to get 2, x minus 150, and x minus 80. So then, that's equal to 0. We solve for x's. This could equal to 0, or this could equal to 0. I get x could equal to 150 and 80. So those are my two dimensions. And look how neat this is. If I add these together, what does that give me? 230. And look at this dimension here. So if I go 230 minus 150, that gives me 80, which is that side. 80, 230 minus 80 gives me that, 150. So my dimensions are, the distances are 80 meters and 150 meters. Okay? All right, last question, but it's a bit of a longer one. So here we go. It says, we have a concert theater company here, and they're selling tickets. Okay? So 720 season tickets holders right now, and their price per ticket is 140. Now they hire in some fancy schmancy research consultant, which could be you in the future, and they say, well, how many people will not buy, how many season ticket holders will I lose for every time I increase by $5, because I want to increase the price? And they say around 20, okay? So the manager decides the price increase of a multiple of 5, so for every time he increases the tickets by $5, he'll lose that year 20 season ticket holders. Now, let's try and solve this out. Rearrange, realter here. Okay. So, first of all, if we have 1, that is the same as 140, and we're going to go plus 5 multiplied by 1, which just gives me $145 ticket. Okay, so number of season ticket holders then is going to be 720, and we're going to take away 20 multiplied by 1, because there's 1 increase. Okay, which gives me a total of 700. Now, I multiply those together. That's 145 multiplied by 700. That's going to give me a total of, okay, $101,500. Okay, that's going to be his revenue, because that's what we made from this. So 720, you increase, you lose 20. 140, you increase, you gain 5. Okay? See how that works? Now let's try 2. We have 140, we increase twice. And every time we increase by $5, right? $5, 2 times. So then we're going to get 150. Okay? So we have 720. That means there's 2 increases. We decrease twice by 20, which gives me 680. So I have to go 150 multiplied by 680 will end up giving me a total of 102,000. Let's try number 5. Or, sorry, an increase of 5. So that's 140. And we have plus $5 increases. We want 5 of them. 5 $5 increases, which will give me $165 per ticket. So that's 720 people originally, but we're losing 20 people for the 5 increases, for each 5 increases, which will end up giving me a total of 620. Now we go 165 multiplied by 620 gives me a total of 102,300. So that's a little bit of an increase. Now let's try the next one of 10. Okay? So once again, we're going 140, okay, plus 5, and we increased 5 10 times. Okay, $5 10 times. So it's going to give me $190 a ticket. Very expensive tickets. Okay? Now, I don't think this is going to be as good, because now we have, out of 720, we are losing we're losing 20 10 times, which is 200 people. So now we're only down to 520 people. So we have 190 multiplied by 520, which gives us a total of $98,800. Okay, that's it. Now, let's take a look at the x. What happens if we call it x? Well, we have 140. We're adding 5 x amount of times. Oh, look at that. We're adding another variable. The thing that's changing is this number here, and it's consistent, right? It's how many increases. That is my x value. Now we're going to go 720 subtract 20x. So what is my value, my revenue? 40 plus 5x. And we multiply that by 720 minus 20x is equal to revenue. Whoa, look at that. Look at this. This is now, we can make a quadratic equation out of that. And here it says, write the quadratic equation. Okay, so let's write the quadratic equation. We're just going to take this and multiply everything out. So, my quadratic equation in term Rx, revenue, is equal to, so let's multiply 140 by both of those, 5x by both of those, and you'll end up getting negative 100 x squared plus 800 x plus 100,800. Okay? So all I did was I did my distributive law. Okay? Everything was multiplied together. 140 multiplied by 720, then 20x, 5x multiplied by 720, and then 20x. Okay? And I combined everything together. Next part here, see, it says, write a quadratic equation which can be used to solve this. Okay? So, we want, how much would he charge for that revenue? Well, that means Rx is equal to that, because that's what we want the revenue. So we want 102,000 must be equal to negative 100 x squared plus 800 x plus 100,800. Okay? Now, let's take a look at D here. It says, D wants us to solve the equation in C to determine the number of $5 increases required to generate that. So we're going to solve that equation now. So let's quickly write out my equation again. I'm going to have 102,000 and it's equal to negative 100 x squared, and we have, what's a plus or minus? Plus 800 x, and we're going to have plus 100,800. Okay? Now, in order to solve this, what must I need? This must be equal to 0. So I'm going to have to subtract 102,000 from both sides. Okay? So, I'm going to now solve this. I'm going to get negative 100 x squared plus, okay, let's take a look at this, 800x, and this is going to be the same as, it's like 2,000 minus 800, so that's negative 1,200. Now, time to solve this here. Let's factor. We have a quadratic equation, we can factor. So I'm going to divide everything here by 100, because 100 can be taken out of everything. So negative 100, so my x squared is positive. And I'm going to have plus 8, minus 8, because everything's by negative. Negative into everything. So minus 8x and plus 12. Now I could use my trusty box method. Or could use it on the graphing calculator. If you're using the graphing calculator to do this, you could do that as well. Okay? Or you could use the quadratic formula. I use the box method because I think this is nice and simple, this one. It's good for box method. 12, negative 8. So we need two negative numbers because that's a positive, negative 2, and negative 6. So we have 100, and we're going to have x minus 2, and here x subtract 6. All is equal to 0. So this can equal to 0, so x subtract 2 can equal to 0, or x subtract 6 is equal to 0, so x is equal to 2, or x is equal to 0. So he could have 2 or 6 increases. Will make 100, here, will make $102,000. Okay? Just going to back this up. Let's see. All right. Take a look at this next one. It says, determine the cost of the package of season tickets and the number of season tickets for each of the instances in D. So we want to know what would be the cost after 2 increases. So for 2 increases, what is the cost? Is equal to, remember, it is 140 plus 5 times 2, because there's 2 increases, which will give us $150. Okay? Now, how many people will buy? How many season ticket holders will there be? That's going to be 720 minus 5, or minus 20 multiplied by 2, which is going to give me 680. Now, let's take a look at the next one. If we have 6 increases. So, my cost, that's people. So, my cost is equal to 140 plus 5 multiplied by 6. Okay, so that's going to give me $170. Now, people, or tickets, I should say tickets, not people, is going to be 720. Now subtract, and every time we're going on 20, 6 times. Okay, which will give me, that's 120, 600 people or tickets sold. Okay, season tickets sold. Now, by graphing the revenue, determine the max and min which could be used. So we're going to now graph this here. Okay, so I'm getting my trusty graphing calculator, and I already have it typed into my y equals. Just do this here a little bit more. See that? So I have that all into my y equals. To save time, I punched it all in. Okay? Now, my window, I made my window like this. So I said negative 10 to 25 because basically he could also lower the tickets by $5, couldn't he? If you want to find the max, maybe the max is if you decrease the tickets by $5. Don't know. And I said my max is 25. I don't think it is if you decrease. Max is 25 increases and 10 decreases of $5. Okay? Now, my y min, I said is 0 because you're not going to make no money. And my maximum, I said, is 125,000 because I can't see it being more than 120,000 just based off the table on the first page. So I'm going to graph it. There's my graph. So now we want to calculate my maximum. So we go second, calculate maximum. So left bound of where the max is somewhere around there. Let's go right bound. Keep on going to the right of the maximum. Yep, that's right on my max because the max is around there. Now my guess on where my max is. Let's see, I'm going to say it right there. Push enter. And my max is 102,400. Okay? So $102,400 is my max, and that is 4 increases. So 4,102,400. Put that right there. That is my vertex. So what does that mean? Well, after 4, okay, so which could be generated? So the revenue generated, well, the tickets revenue will equal 102,400. Okay, there will be, the ticket cost will be 4 multiplied by 5 plus 140 is equal to $160. Dollars. And how many people will buy tickets? I'm just going a bit farther. That's 720. And I'm going to subtract 20 multiplied by 4, which is going to give me 640 people. Okay? Hope you understand that. If you have any questions, don't be afraid to